Hello there, my name's Vince from My Mate Vince, and look what we have here. A Cisco Small Business Hub SR2024. So 1000, 1000 switch. In other words, it will go fast Ethernet and gigabit as well. Let's forget about the 10. It's a 24 port switch. Lovely looking thing. Let's get it unpacked. Bought it from eBay with no power. Let's verify that it has no power. Look at this. Really good condition. So you have your 24 ports there. Couple of little holes here. I think that's if you were to include fibre into it. And it didn't come with any power. It's got like a kettle connector at the back. So it didn't come with any power cable. Turn it on. Hasn't gone bang. I know my cable is working. And we don't have any lights. I presume the system light here should light up. Let's bring it over to the mat and let's see if we can get this fancy switch working. It's not actually that fancy, it just looks nice. And in case you're curious, this is just an unmanaged switch, not a managed switch, but ideal in like a house environment when you just want to share the connection to all the different rooms. Lovely logo, isn't it? Now, I cannot see any screws on here, but we have got these little mounts here. So I'm just going to undo them because there's a line through the middle. So I'm thinking it somehow separates, but there's no screws here. There's no screws here unless they're hidden here. I don't think they are. So I think annoyingly it's going to be clipped into place. Using the Anders screwdriver, Linus Tech Tips. Anders after the guy that bought it for me. Runs the My Mate Vince fan club. Yes. If you're wondering what's happened to my hands, look at that. It's like I've been shaking hands with Freddy Krueger. I had to change the gearbox cables on my daughter's little Fiat 500. One completely snapped so it wouldn't go in to gear. So you have two cables, I think one for up and down on the gear stick, or left hand, UK car, and another cable for left and right. So I actually enjoy doing it. It's just, it was space is lacking. And I had to do it in the university car park. So yeah, she pulled out and then it just didn't snap. So luckily, she just got it pushed back into place. And then I had to deal with it, which isn't easy. It's not even easy if you had it at home, but when you're working from a car park, it's even harder. Had to take the gear stick out and everything. Had to get under the car. Then it wouldn't go into fifth gear, but it just needed adjustment. I enjoyed it. Right now, I can see if I pull that this here might want to come away. So I'm wondering if I can prise off the front or prise off the back, and then it might give me more access. Either way, I need to somehow separate this. So let's try with the, let's get a plastic pry tool. I don't think it's going to be strong enough, but it will please the audience before I move on to metal. Oh, there you go. Can you see that wants to break there? So I've got to be careful. I'm going to go over to metal because I think I'm going to do more damage with the plastic. Let's start from this side. It might be stronger. So how do you come out? Do you come out here? Let's go underneath so the scratches won't be seen as bad. My word. You think for a product like this it would just have screws, because it's not exactly an Apple product. It doesn't need to look great. Oh, that was successful. Oh, scratching this up nicely. Come on. That's good. That was a good one. So why is it comes out there, but why is it not coming out of the edges? Ah, oh dearie me, pinch me! It's not coming out from the edge, from what I can see. Ah, think I have to pry that out separately. Maybe I should go from the front. Oh, look at that. There we go. Right, so 1, 2, 3. There's 4 connections there, so it must be the same with the top. Easy when you know. Let's use this and try to get under. Oh, look at that. I tried to Google this model and there's no videos on it at all. There's only one video where the guy has, I think, 555 views, and all he's got it on the turntable is just spinning for 5 minutes. Right, we are in. Oh, the little, have a look here. Can you see there's little things sticking up here, and also there's one here, and there's one here. They're like hooks like that. So we need to push it forward. We need to push this forward. Come on. Let me try now and do this thing that I was doing at the back. Oh, Vince. Oh no, that was the top. I should have done that underneath. Ha ha. Oh, that's annoying. But I have fixed it. I've devalued it now. If I do fix it, I should say. Right, are you going to push out? No, because I need the top to push out, not the bottom. So I have to get in here. It's moved a little bit. I'll tell you what we're going to do. Let's go here and lever. You can see how much strain has been put on us bending this. Go back to the plastic. There we go. Did you hear that click? And now look, that's come away there. Right, let's do the same this side. Okay, so you don't really need to get involved with doing that bit there. If you can get something in here to prise it open. Well, now I'm going to get the "you're like a bull in the china shop" comments. I think sometimes when people say that, they've never taken anything apart, because you can see how much force I'm putting into this. You can see it's bending metal and stuff, so that's why sometimes it's easy to slip. There doesn't seem to be any technique apart from using that strength. I thought when that came out that this side was going to be easy, but it is not. I think if I got a hammer and tapped it with a little screwdriver, I think it would come off very easy then. My word. Right, let's see if I can just do this. Oh, there. We're out. So as long as you do one side, you're okay. Back's held in with these things here. And we have this here to protect the power supply, or to protect this from, I presume, becoming live from the power supply. Right, so apart from the scratch, I did okay, and I might be able to get some of that out. Right now, so that's off. That's where the power's there, so we don't have to worry about this, and this is this here. So what we need to do is we need to plug it in, and we need to see, is there anything going through this power supply to here? Because we've got 2 reds and 2 blacks. And then we know whether it's going to be a problem on this board or this board. So what I'll do is, just in case this board is, well actually, to begin with, let's just do that first of all, and then if we don't have anything, I think we should unplug it and then see if we have anything, in case there's a short on here, which is knocking it out. Looks like we have 3 chips, massive heat sinks. 1, 2, 3, 4, 5, 6. 6 of these I don't know what they are, but obviously they're to do something with the ports, aren't they? 1, 2, 3, 4, 5, 6. So each of them must do 4 ports. Huge capacitors, massive ones. I don't know if I've seen surface mount that big before. All looks very clean. There's no cooling fans or anything like that. So let's gently plug it in, make sure I don't put my hands anywhere near here, and then see what we have here. So we're going to go on to volts DC.
You're probably sick of me saying this, but don't copy what you see in my videos. Take it purely for entertainment. Working on power supplies is obviously dangerous when it's plugged in and you've got mains voltage. There's easily enough voltage there to kill you. So don't copy what you see in my videos. Just take it purely for entertainment.
And we're going to go in here and here and see what we have. When we plug it in this last, so I'm going to plug it in now, keep my hands well away from everything. Right, so we have nothing there. Right, what I'm going to do is gently go onto AC. Let's just make sure we've got it coming through this adapter here. So I'm just going to go, I'm not touching the probes, the end bits obviously, I'm just going to go here and here, and let's see if we have AC coming in, which we do, 246 volts. So that says to me, I'm going to unplug it, that says it's something to do with this probably, but there is a chance that there's something on the board that's putting a short on. So I think what we need to do is I think we need to disconnect this. I've got to be careful because there still might be charging that massive capacitor. And but it might not even be getting there, you know, it could be the fuse or something. But we don't have anything. We don't have anything here. Not sure what voltage we should have here, but I don't think this is a PoE one. But I don't actually know, I didn't look up the specs. Right, let's disconnect that, and now let's see, let's put that out of harm's way here. Now let's go into here and see if we have anything. Also, I wonder, are these joined together? Yeah, blacks are joined together. And the reds are joined together. But we have no shorts. So let's do that again and see if we have anything now that that's unplugged. And then it will suggest if the board's on, the problem's on here or here. Right, so I'm plugging it in now. So it's going to be live. Hands well clear, going in. So it looks like it's a power supply problem. Good and bad news, maybe not quite so interesting for the video. So power supplies are incredibly hard to fix. It would have been nicer if we were fault finding this board here. But I probably will have more spares for the power supply than I do the actual, I'm unplugged again, than I do this here. So we've got two, I'm just going to leave it a few minutes. We've got two screws here, a screw here. We need to measure that big cap to make sure there's no voltage in it. I'm being careful not to touch this when I'm undoing it. So let's just turn this over, measure the cap, which is here. So it's going to be those two prongs there. See what we have. Nothing, and I've poked in there pretty hard. So I don't think power is getting to the cap, unless of course it's drained very well. So I feel safe to work on it, but just in case, I'm going to get my insulated little pliers here, do that. There we go, so I'm just shorting that now. So I'm okay to work on it. Let's unplug this. Right, well, I can't see anything burnt, so this might be an interesting one, hopefully. Let's start fault finding. Right, now, so we're going to zoom right the way in and we're going to go into continuity, and first of all we're going to see if it's going from here through the fuse. So on continuity, my meter will beep. So it's coming in on the outer two, wasn't it? Yes, the outer two, so let's ignore the middle pin. And from here, we've got a big sticker in the way. I just want to see what's happening. Let's take that off for the moment. So where are you going to begin with? So the fuse is here. First of all, let's see if it's going through. So the fuse is going, I think, between here and here. So one pin here goes along through the fuse. So it's going to get from here to here. From here to here. Does it go here? No, fuse has gone. Now, why is the fuse gone? Has something caused it to go? Let's just check the other side. So here to here. Yes. Here to here. Where'd you go then? Where do you go then? It goes through this thing, doesn't it? Hold on, here to here, here, and then it goes through here into the bridge rectifier. So and then the other side should go through the fuse, so it should go to here, which then will come to here, which I think will come up to here, goes through here into the bridge rectifier. So I think we need to test the bridge rectifier. This is the bridge rectifier here. This will turn the AC into DC, and you can see the middle two symbols are AC, and then this is DC, negative and positive. So we're going to go on to diode test on our meter. And in fact, we can just do it from here. Let's just see if we have any shorts. So I'm just going to go, I don't know where I'm going to go. I'm just going to go here to begin with and go across them. So I have a read in there, a read in there, and a read in there, but no shorts, because if there was a short, it would look like that. Now let's swap the leads over. Still got a read in there. Still got a read in there. Still got a read in there. Okay. We have readings. I thought on bridge rectifiers you should have a read in one way. So look, we haven't got a read in there. Oh yes, we have. I think this is going to be the same as, what did I do recently? The aerial thing. So we haven't got a read in here, or here, or here. But now if I go here, reading, reading, reading. So I would say that looks right. But look, when we do this one here, that side of the AC, we have a read in, you know, both ways. So I think the fuse has been taken out because the last time it was something to do with the switching transistor, which is where? Here. I bet you this thing here. Oh, and it's a four-legged one. It's a Fairchild. Oh my word, no way. 4 legs. When I did the aerial, when I did the amplifier aerial, the you know, the big aerial splitter, satellite splitter, I said I don't think I've ever seen a 4-legged one of these, and it was Fairchild. Now this is another 4-legged Fairchild, and I seem to have the same fault conditions. I think this here has failed and has taken the fuse out. That's what I think. Right, so we need to get it out of, well, we don't need to get it out of circuit yet. Let's see if we have those weird things on here as well. So look, 1, 2, 3, 4, I think. No, 1, 2, 3, 4, these 4 here. So let's just see if we have those weird reading going both ways on this. So it wasn't a full short. It was just that we had readings both ways. Like that. Yeah, see here and here. I'm going to say that that's gone faulty and that's taken out the fuse. And I think if we were to be able to find a replacement, I think when we go across here, that one there, I don't think it would be reading both ways. So I think when we take this out of circuit, I think the bridge rectifier will now be reading normally. So let's, that's so weird that I've come across one so soon after the other one. How am I going to take this out now? So I have a screw here that I can actually get to. So I think I can leave this in place. I think all I have to worry about is taking this out, because I have access to it. So let's undo this screw. Oh, there you go. If there was ever any doubt as to whether or not that was faulty, I tapped it with the screwdriver and look what happened. How good is that? The bottom bit's come off. Well, I think we can safely say that that is the faulty component. Luckily though, I've still got this here and it hasn't burnt. I can clearly see that it says 5H0335H. H 0365R. Why that annoys people so much? Zero idea. Still think H sounds better than H. Anyway, that's it there. So let's take it, let's unsolder it. How good was that? That looked perfect before I touched it with the screwdriver. And you can see they've insulated one leg just there. Right, are you going to come off the back there? Yes, you are. Very little thermal paste. I wonder, could that have been the problem? Where's the thermal paste here, Cisco? Where's the thermal paste here? There isn't any. I'm not sure how hot this actually gets, but hot enough to have a massive heat sink. I think there should have been a little bit, not that I know, but I think maybe there should have been a little bit more thermal paste there. Maybe it failed because of that, maybe not. I wonder, is it those two pins that actually failed? Let's see. Reading that way. And then reading that way. You never know. It's that pin there that's gone. So I think. So it could be related to maybe that side got hotter. Let's unsolder it. Desolder it, I should say. H again. Right, let's flood this area. So I'm just adding leaded solder to make it easier to come undone. And I'm going to use my solder sucker, but just a manual one. I can't be bothered to wait for the other one to heat up. There we go, that one here. Working nicely because it's clean. So, oh, look at that, nice. Oh, this is working very well. Nice plug as well. Woo! Let's see if I can get 4 out of 4. Very nice again. This one's been bent over. Nearly got it all. Nearly got it all. Just going to try to lift that up. There we go. I wonder, is that going to be free enough? I think it might be. No, that's stuck there. There we go, they're all loose. That should pop out. Ta-da! Excellent, I'm going to take a picture of that because otherwise I'll forget which leg the thingy should be on. The heat shrink. Just in case I lose that. So, like I said in the other video, and I could be completely wrong because I haven't actually released it yet to see the comments. I think it's gone to the Patreons. I think this has failed because often you have the you have a chip and then you have like a switching transistor, and it's the chip that's doing the switching transistor. I don't seem to have any chip here, sorry, this side here, and I mean, what's that? That's just a double diode, but there's no chip on this side. So I think this is doing a lot of work, hence the reason we have the extra pin. I'll know when I release the other video, but I think that this is probably quite a stressed component. So maybe more so stressed than other components in the switch mode power supply. Right, let's see what's happening now on this bridge rectifier. Let's see if we have those readings going everywhere again. So I think it was on this one. Whoops. Diode test. Excellent. Nothing there now. Nothing there now. Oh, something there. But now if I swap over, something. Nothing. Maybe that's normal. Nothing. Okay. I don't know the proper way. I just test a bridge rectifier by looking for something one way but not another way. So that's a prime example. So look, if you're on the red one here and I go here, but I don't actually know how to test it. But you can see I have a reading on every pin that way, but when I go here, I don't. So I would say now that that's probably okay. Reading, reading, reading. But if I swap it over, then I should have no readings. I'm going to say that that's okay. I think, just like the aerial one, I think that this has failed, which has taken out the fuse as well. And the fuse, if we zoom in, see what that is, let's see if we can still get spares. Fuse should be no problem. So this is a so it's a 1 amp, 250 volts. Yeah. Okay, let me do a little bit of research and see if I can still get these chips here. Right, they're quite pricey. Interestingly, the one that I bought for the aerial amplifier, I think that was up on like £12–13 or something. And the same company is doing it for £10.79. It's a slightly different number. It's the same thing, 4 legs, but it's the other one I've got is different, while this one here is 0365. So obviously I want to get like for like, but I'll probably go for that one. I have bought from this company before, I recognise that. That's a Little Diode, I think it is. And you can also get them from China. The reason I didn't get them from China on the last ones, I'm pretty sure that was the video where the reviews on AliExpress said that they were fake and they don't work. Not sure. They are very expensive chips. I also need to get a fuse as well. So you can see by the time I've bought this one here and a fuse, I'm going to be probably looking at about 14 to 15. I know fuses are not a lot, but still there's going to be £15 worth of spares. So not cheap. These chips are expensive, but I presume they're relatively rare. So I'm going to get one and get a fuse, and then hopefully when we pop them in, it might well just be that.
A while later.
We are back once again, and my spares have arrived. So let's zoom in, make sure that this fuse is the same as this fuse, and let's make sure this is the same as the remains of this one here. So this fuse is T1 amp 250 volts, and these ones are T1 amp 250 volts. And this new component is 5H0365R, and the old one 5H0365R. Right, let's get them soldered in. So we have to solder both the components in. I have to desolder the fuse that's already there using my little solder sucker. It's slightly glued into place with some kind of yellowy silicone stuff, and I just need to snip that, take the fuse out, put the new fuse in, all nice and straightforward. When I put the new 4-legged component in, I do have to bend 2 of the legs because they're staggered, and I have to put a tiny little heat shrink on one of them, just because it was there originally. Not sure why. Is it to stop the possibility of some kind of arcing? Is it to reduce some sort of switching interference in between that and the pins next to it, the legs next to it? I do not know. But it was there to begin with, so I'm copying, hopefully, like for like. And then I just need to solder that in place. But I'm screwing it in first, because if I solder it in and the screw hole doesn't quite line up between the heat sink and also the hole of the component, then they're very easy to crack because there's an awful lot of force put on when you screw them in. I knew that because it's happened to me before, so it's always best to put the screw in first, then do the soldering, because then you know it's going to be in place nicely and it's not going to be fighting against the solder. Then I need to just give it a little bit of cleanup of IPA, and also I'm going to just use the a tiny bit of glue again to glue the fuse back into place. Maybe it's just to stop a bit of vibration or hum or something like that, not too sure. Also, I do use MXK thermal paste on. Of course, I use the incorrect amount, as I always do, and I spread it around the place, but I do make sure that the whole component is covered in thermal paste. Now, I know with thermal paste it's only supposed to do it, let's say if it was a perfect component and a perfect finish on the heatsink, then I don't think you need thermal paste. The thermal paste is to take up if there's any little gaps or anything like that. But yeah, we've seen that there was a bit of thermal paste on one side and not the other side. Possibly that could have led to a gap off, I don't know, 1/100 of a millimetre, and maybe that was enough to cause that part of the chip to heat up. So I'm just putting the thermal paste over the whole lot, and that way then hopefully the whole chip itself will be able to dissipate its heat. While I'm doing this, I'm going to give a shout out to the My Mate Vince Massive. They are the top level Patreons, and the members this month are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeves.com, DJVG, Pigsy, Russ Melanson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, Garen Shaw, and Lady Leona Drury. So a massive thanks to each and every one of you, as always, and also a thanks to all the other people that support over on Patreon. So anyway, I have this back together. Let's plug it in, and hopefully we'll have that green light working, and this will be outputting a voltage, which it probably hasn't done for quite a few years.
Right, so that is back together enough to test. Let's plug that in there. And what we could do is, let's get this multimeter and see if we have a voltage going into here. Right, I've got my lead. I'm going to plug it in here to begin with, then I'm going to reach over and plug it in. Now I should be doing this with a dim test, a dim light bulb tester thing, where it's if there's a short, because there could be a short on here, couldn't there? We don't. I'm thinking this has failed, which is taking out the fuse, but I have actually no idea. And what would happen is the light would light up rather than, and it would save things like constantly replacing the fuse. But I feel confident. I actually do feel confident this is going to work. So let's plug it in and see if we have our voltage here. And also, I'm assuming this little light is going to light up here, I think it is. So I'm slightly wary. I've got my face away, but I'm being brave. I'm plugging it in now. I'm in. Okay. Why haven't we got anything? Why haven't we got anything? I'm unplugged again. Why haven't we got anything? I didn't check the fuse. Whoops! There goes a box. Well, I wasn't expecting that. Okay, what we'll do is, I am plugged in there, aren't I? Let's unplug this from here, just in case there's a short on this board. And let's do that. I mean, it didn't go bang. Let's plug in again and see if we have anything. In there. No.
Ha ha.
Well, that's annoying. So I wonder how far the voltage is going. All right, well, I'm unplugged. Let's, we've got more fault finding to do. Let me just double check. I did do this earlier, I'm sure, that these two are linked. Yeah. Here. There's no short between them. Well, I've got to be careful now because it could well be charging that cap. Let's undo the circuit board. I was sure that was going to work. So first things first, do we have anything in the cap now? We do. We do have something in the cap now. So I wonder if we plug it in, will we have full voltage at that cap?
So that means then I'm thinking the bridge rectifier is not going to be shorted. Got a reading there. No reading, no reading, no reading. Okay, so we've definitely made it better than before. Should we try these diodes here? Then I'm going to have to plug it in and measure the... hold on, that didn't look right. Hold a minute, that diode shorted. Look. That's a short. Let me check the diode on this side here. Annoying, I'm not going to know what diode that's supposed to be. There you go, you can see that's not shorted. So I think that's gone wrong. Oh, annoyingly, that's ZD, that's a Xena diode. So what on earth is that going to be? I'm going to have zero clue what that is. I can see it says ZD1. So that's going to be a Xena diode. Unless I was to take apart the satellite receiver that I did, because I know that that has a similar chip on it here. And maybe I could see if that's a Xena diode, I might be able to get a... Well, I'm still not going to be able to get a reading from it, am I? There's no markings. Let's have a look at this diode here. That's a reading one way. And does that go to... let's zoom in. Does that Xena diode actually go? Let's go to continuity. So you'll hear it beep. Maybe it's just the Xena diode that's failed. If you have a listen, can you hear there? And I'm just going to go to ohms to see what short that actually is. So if I put my leads together, it is 1.5 ohms at the moment, and if I do this, it's 1.58, so you can see it is a direct short. Now where do you go to? So this is the thing that I've replaced. Where does that go? That's a link to there, so that's linked to here. Yes, then where do you go? Here to here. Is that linked to that or not? Is that linked to that? So what is the Xena diode actually linked to? These two. So it's shorting these two. What are they? Oh, the optocoupler. Ah, well that suggests why it's not working then. Okay, so we've got a Xena diode across the optocoupler. If I Google that, that might be a kind of standard thing. And I think I bought a kit of Xena diodes ages ago. So this should be 68,000 ohms. Let me just see if it is. It might be just that one Xena diode that's gone. No, that doesn't seem to be. Oh, is it reading across here as well? Huh? Wait a minute. Are these the same? 683. Yeah. Right now that's 76,000 ohms and growing. And this one. Oh no, 71,000 ohms. Okay, maybe I wasn't on it properly before. 71,000, yes, that's close enough. Okay, I think it might be just this Xena diode. So let's take it out of circuit and let me just take a picture so I know that the black band is here. Is this a Xena diode here as well? Can't quite see the markings. Yeah, ZD1. I think. 02. ZD1. Just want to see what ohms that is. Yeah, it's like 1,000 ohms. Right, let's take a picture and unsolder it, but I know it looks to be the same as that one there. Let's take it out of circuit. Just in case, it could be the optocoupler that's shorted. It might not be the Xena diode. So I'm going to have to use low melt, aren't I? I don't think that's going to come off. No. Let me get some low melt on that. It's a nice mess. Thank you. I've managed to solder it onto the braid. There we go. Add some flux because there's just a big mess. This will hopefully sort it out. There you go, look at that. Beautiful. Right, let's give that a little clean and then we can work out if it's the pads that's shorted or the Zener diode. I think that's a glue. Oh yeah, sorry, they're wave soldered, aren't they? Look, can you see? They're all glued down and the wave of solder comes across. So all the black bits are where they're glued into circuit, so that is glue there. Right, okay. So we've got our Zener diode there. Let's see where our fault is. Got it on continuity? Are the pads shorted? Da, 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 da. No, they're not. Is this shorted? Yes, it is. Now, I've got a big problem because I'm not going to know what that is. We'll zoom right in, but I don't think there's going to be any colour bands on that or anything. I've cleaned it up. Well, let's see if there is any markings on it. You can see some bands on it. I'll zoom right in. Oh, it does say something on it. 2. Ah. Ha 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 ha. It says C2. C2. Let's get the microscope. Okay, so that is definitely a C. What do we have next? 2. We definitely have a 2. What do we have next? It has to be a 7, doesn't it? Going up here. What do we have next? C2. I can't tell whether that's just a remains of glue. I'll tell you what, let's see how easy the C comes off, because we definitely know the first one's C. Let's see how easy it comes off. Oh, annoyingly, very easy. So the worst thing I could have done there was probably use the IPA on it. So I'm going to see if C27 means anything, but I think there's something else after it as well that I've got no way of knowing what it is. C27. Bear with me. Now obviously I don't know if it is a C27 diode, it could be a C27 1, 2, 3, 4, 5, 20, 30, 40. I haven't got a clue what has been rubbed off after that. But a C27 Zener diode does exist. It says here, small signal voltage regulation and stabilization. High power stabilization and clipping circuits, 27 volts. I mean, they cost next to nothing. I'm going to see if I've got one. Also, I'm going to put in between, let me put C27 Zener diode in between legs off
optocoupler and see what comes up. But you can see that they're definitely a common thing. Right, so I think it's used as protection, so it might not actually be that important, or what I should say is that maybe the circuit might work fine without it. So it's not going to work with it in because there's a short across it, so the LED on the optocoupler is not going to light up. But if it wasn't there, then I think what would happen is the optocoupler would have more chance of getting damaged. Even now, because this is completely short, maybe if there was a high voltage spike on it, then it might have, which I presume there has been, then the optocoupler might also be blown. But it says placing a Zener diode, so it might not be actually that important if I haven't got the correct one. Or maybe I won't know I haven't got the correct one, because maybe it would work no matter what Zener diode I put in there, but maybe under fault conditions it's not going to work properly. Placing the Zener diode between the legs input pins 1 and 2 of an optocoupler's internal LED is a common design technique used for protection, threshold adjustment and noise immunity. The Zener is typically placed in parallel with the LED, with its cathode connected to the anode of LED pin 1 and its anode to the cathode of LED pin 2. And the primary reasons are for reverse voltage protection, threshold adjustment, input high-low, noise suppression, preventing overvoltage over current, which is, I presume, is what's happened here. In AC input circuits, a Zener diode combined with a series resistor restricts current flow to a safe value, preventing the LED from pulling too much power. So the same way as you put a resistor in series when you're doing an LED, because otherwise you're going to put too much current through the LED and it's going to burn out. Maybe it's similar to do with the optocoupler as well, possibly. So right now the optocoupler might also be faulty, and the reason it's not working is because if the feedback circuit's not working, it's going to, I presume the output of it is telling the input not to work. If I replace this with a Zener diode that I think is correct but I have no real idea, then it still might not work because the optocoupler itself, the LED, might have failed. And if the LED hasn't failed, it can't do the feedback between this side and that side there. Because if you have a look, the optocoupler is actually across the input and the output, so the primary and the secondary, the hot and the cold, the higher voltage and the lower voltage. So it can only be done via lights, because otherwise there would be a path in between. So imagine kind of like a lighthouse beaming a light and then a ship saying, yes, I see that light. There's no path, there's no electrical path between the two of them. So yeah, okay, let me see if I have a C27. Right, so this is my Zener diode kit. Now with a Zener diode, where it's different than a normal diode is, for example, when we use this, we can see that we have a reading one way on the diode but not the other way. So when we have the leads one way, it will work, another way it won't. So it's going to allow the signal through one way but not the other way. With a Zener diode, it's the same as a diode, but then when the voltage gets to a certain amount, it will allow it to go back the other way. So it will work this way and block it this way, but once the voltage climbs to a certain amount, then it will work this way. So but obviously I'm not going to know what it's designed to do. But here we go. Why don't I just have a look here? CV, here we go, C27, 27 volts. I'm just going to stick one of these in and see. Is there anything which is 27 over, you know? As in 27.2, 27.3. I don't think there is. I think I might actually be okay. So BZX55C27. So all I'm looking for is 27 volts then, isn't it? 27 volts there. This one here. I haven't used this kit before. I'm going to stick one of these in and see what happens. So this does have legs on it, but it's fine. I'll make it work. You can see that that has massive pads either side. Not pads, like ends, caps either side. While this is through hole, but it'll be fine. So let's just see if this is working like a diode. Because remember, that was a full short. So reading that way, but we shouldn't have a reading this way. No, but I presume if we went to 27 volts, then we should have a reading that way, I think. Could be completely wrong. Now, I've got to stick this in the correct way. So I can see that the black mark is there. So let's do the same here. We're going to be putting it on. Really, I could even just put it across there, couldn't I? But I'll put it back onto the pads if I can.
So I'm going to push this down. I'm going to cut these very short and try to bend them back on themselves. Right, so we know that that pad is linked to this pad here, yes? Let's just double check that. Yes. That's linked to there, and they're not linked to each other. So I can just put it between this pad and this pad. And the black is going to be on this side here. Right, so there's no way that's going to short to there, and that's not going to short to there. So if I flood both of those bits with solder, I think it will be alright. Like that. And like that. Oh, that's pretty nice, is it not? And it's glass all the way to, you see the pad underneath, it's glass all the way to there, so it's not going to be shorting there. It's not going to be shorting on that pad. Right. Quite low voltage there anyway, isn't it? I think. So let's see now, is it reading a diode? So if I go between the legs of the optocoupler, you can see we have a diode that way, and we don't have anything that way. And there's no short there. No reading. And a reading. Right, now let's plug it in and see if it's going to work, or is it still going to be completely dead because of the optocoupler. Place your bets. You ready? Here we go. Here we go. I'm going to plug it in here first, keep my hands well clear. There's nothing that's going to short anywhere. I'm plugging it in now. Please don't go bang. Please don't go bang. Plugging it in now. Please don't go bang. Yes! Yes, yes, yes. 12 volts. We have a green light on. Can you see the green light on my finger? We have a green light. Can you see it there? Hopefully you can see it there. Let's lift it up carefully. Look at the 12 volts. We have a green light. Ah, results. Results. So, I think this blew, which took out the diode, and also took out the fuse as well. So it was that, and there should be a fuse here. Three things making this faulty. Money-wise, was it worth fixing this? I've got a feeling the amount I spent on that 4-leg component there, I might have been able to buy a working one of these. But it does look incredibly good condition. Oh, we even have a little green flashing light there, which is nice. Okay, let's put it back together, and let's see if we can actually get it working. Brilliant. Well happy. Here I am, back in my hidey hole for the second time this month, and I've just temporarily thrown it down here. And this is the network switch I usually use, and it's been flawless, it's worked perfectly. Little Netgear one here, little 8-port one. And I've just plugged all the cables from there into here. And you can see not everything's connected at the moment. Like, for example, my son's Xbox would be off completely, not even plugged in. So that might be number 8 or number 7, and that's why we don't have any lights there. But if you have a look here, we have lights here, and it also says which ones are gigabit as well. Interestingly, I've got a frame TV, and the frame TV is brand new, yet it's not gigabit. When it comes to Ethernet, it's only fast Ethernet, which I thought was very interesting for a new Samsung product. But you can see there, it's hard to zoom in, but can you see gigabit there? You can see on number 1. So there you go, they're flashing away. And if I was to move that, I've just tried a couple of other ports. I haven't tried every single one, but they appear to be working. So for example, if I was to use number 1 and plug it into number, unlucky for some, 13, you will now see in a few seconds that 13 has now lit up here with the gigabit. I'm just going to put it back into 1 because I like this to be in order
when it comes when I plug it back into this. I could start using this, I just don't really need it at the moment because 8 is enough for me, but it probably would fit quite nicely. I could actually put it across this side here maybe, because these just by chance happens to fit in this hole perfectly. This is where there used to be an air heater, so there was a boiler, gas run, that ran through a heat exchanger here, and this had a massive fan, a huge massive noisy unit which would blow air through all the ducting throughout the house. Very unusual for a UK house to have air ducting, but it's what they went over to in the 70s for a short amount of time. And again, if we were to have a look at maybe number 5 here, you can see it will go out from there, and if I plug it into number 17 it will light up on 17 there. Right, and let me just show you a couple of things working. Love that. So there we have my frame TV still working, and that will be on Ethernet. And here we have my mate Vince on the main TV, so you can see the internet is working. There we have it, one working 24 port Cisco switch, which is nice. Really happy with that one there because I like Cisco products. I've never worked with them, but when I was with BT, I often used to see Cisco products all over comms rooms. So I presume they're good quality because they seem to be everywhere. And looking at this item here, it does look to be nicely made with the metal case and stuff. It just makes you feel good when you hold it. So yeah, I think I'm going to be buying more Cisco products because I quite like looking through them, and you never know, I might be able to build up, and some Cisco things are really expensive. So if I could get ones for cheap and then fix components like that, and then all of a sudden you might be able to make a couple of £100 profit on certain ones of the more expensive equipments. So I'm going to keep my eye out on eBay and see what there is. But in this instance here, my guess is that this thing, because it's working hard, is failed, which took out the Xena diode and the fuse as well. But you put it down in the comment section what you think. Maybe the Xena diode went first, which then took out this and this, but I think it's more likely to be this, the primary fault. I really enjoyed that. Hope you did too. If you did, give it a thumbs up, and I will see you again very soon. Thank you so much for watching.